This is Teachers Talk Radio, and you are listening live.
Good evening, everybody, and welcome to The Late Show on Teachers Talk Radio with Tom Hopkins-Burke interviewing Pete Mattock. We'll be kicking off in just a few moments' time. I'm just going to bring Tom in. Thank you very much for tuning in. If you're listening back to this as a podcast, thank you, and welcome to Teachers Talk Radio. I'm now going to pass over to Tom.
Is it my turn now, Tom?
Yes.
Lovely. I wondered if there'd been some sort of terrible mistake where I couldn't hear you anymore. But never mind, we are here and we are live. Good evening, everybody. Yes, my name is Tom Hopkins-Burke, and it is part 2 of a Crown House special today. We've just come from part 1, which was the Twilight Show with Nathan Ginn at 6 p.m, interviewing Eddie Costello from Square Pegs. Lots of wisdom there. And this is part 2. And I'm joined by Pete Mattock, the author of Conceptual Maths by Crown House, and he's going to be telling us why it's important that we teach about rather than just how to do mathematics in schools. Pete, good evening.
Good evening. Can you hear me all right, Tom?
We can hear you perfectly.
Oh, good. I was a bit nervous with this. I've never done one of these before. So.
Always am. How's you still at school this week, aren't you?
Yes. Break up tomorrow. Half term from Monday.
Lucky you.
Looking forward to a rest.
Yes, well, thank you very much for giving up your time in what is a very busy half term. And we're going to start with a question that everybody dreads, I suppose. Tell us about yourself.
Okay. I've been teaching maths since 2006. I qualified then at various different schools. Started my career down in Oxfordshire in an 11 to 18 school down there. Taught there for just over 4 years. And then January 2011, took my first role as head of department for another school in Oxfordshire, in Oxford City. And then did that for about 3 years before coming back to the Midlands, because I'm from the Midlands originally. And my wife and I, well, now wife, she wasn't at the time, had not long had our young daughter. And so came back north to set up our family. And I've been teaching back up here now, for pretty much since then, as a head of maths at an 11 to 16 school in Leicestershire, and then for the last few years an assistant principal at the same school. And then obviously alongside that, I've got involved in various other different bits. So I've trained with the NCTM. I've and done their sort of mastery specialist course. I've done a few other bits and pieces for things like Teachers TV, TES. And of course, those experiences have come together into 2 books.
Mm-hmm. And we shall be exploring the second one of those, Conceptual Maths, during the programme. I wanted to know, were you always destined to be a maths teacher, Pete? Or was it something that you sort of made a switch to in terms of your career thinking, or were you always set on it?
No, I definitely wasn't always destined to be a maths teacher. I mean, when I started my degree, I didn't even start it as a maths degree. I started it as a physics degree. No, my first career choice was actually going to be army officer. I was an army cadet when I was younger, and I had designs of, as a lot of my friends did, of going into the force and serving. I think I was destined to serve. I think that was the sort of the key thing in it. I always wanted to be of service, and so that was the sort of start bit. But for various different reasons, that didn't happen, and I started to sort of think about what it was I enjoyed about the cadets, and honestly, it was the teaching bit of it more than the army bit of it. So I sort of started to explore that while I was at uni, and sort of wound up with that as my chosen pathway. But like I say, when I first started uni, I actually started with a physics degree with the aim to complete a theoretical physics degree. But I'm sorry to any of the physicists out there, I was bored to death with the lab work. I just couldn't cope with it at all. It just took up so much time. So I switched my lab unit to an algebra unit, and that switched me from a physics degree with a bit of maths to a maths degree with a bit of physics. And I never looked back from there. I absolutely fell in love with maths during that time. I did modules in communicating maths to set myself up as a teacher as well. That was one of the few modules I actually got first in. And then, yeah, from there straight into maths teaching. So it was around the sort of middle uni years that I sort of knew that's where I was going, but it certainly wasn't what I was destined for.
And so, you started with a physics degree before switching to maths, and you didn't always set out to be a maths teacher. Would I be right then in thinking that perhaps maths was not your favourite subject at school? How did you find maths at school, and can you remember anything about how you were taught maths at school?
Yeah, I mean, I was good at maths. I was in the top set. I came away with an A star at GCSE. I breezed the GCSE exams relatively straightforwardly at the time. I mean, they were simpler today. They were simpler then than they are now. The new GCSE is a bit more challenging, but so I was always good at maths. But the excitement for me led in the physics, in the study of the very small and the very big. So yeah, I mean, in terms of my memories of maths, they were perfectly pleasant. I was doing something I was good at, and I think you're always going to enjoy that at a certain level. If you're good at it and you can get it done and it's relatively straightforward, then there's a pleasure in doing something well, isn't there? I mean, in terms of the pedagogy, I mean, it was fair. We're talking about the mid to late 90s, and it was fairly sort of standard. The teacher would show us some stuff and how to do some stuff, how to solve a particular type of problem or how to do a particular type of calculation. And then we'd get a textbook out and we'd practice that for a good portion of the lesson. And then we'd mark the answers, and then we'd all go off and have fun. And that was pretty, the fairly standard sort of maths lessons I think that a lot of people would have experienced in the sort of 90s and early 2000s.
Mm-hmm. So it sounds to me as if you would, and I'm not a maths teacher, I'm a history teacher. I do have an A level in maths, that is as far as I go. It sounds to me as if you would,
which is further than most, Tom, to be fair.
No, I know, but if I get anything wrong, do not be afraid to correct me. But it sounds as if you were taught maths in a very procedural way. You were taught about processes, you were taught about how to do things, whereas your book talks a lot about the concepts behind maths. So for anybody who's not a maths teacher, or for anybody who hasn't picked up your book Conceptual Maths yet, what does it actually mean to learn maths conceptually, or to teach maths conceptually?
Yeah, and I mean, I think that sort of procedural driven approach to teaching maths, again, it was not uncommon for the era, and is potentially still not uncommon, although it swings back and forth a little bit. But I mean, when I talk about conceptual maths, I'm basically going to sum up the interview in this in what I'm going to say. But when I talk about conceptual maths, and it shares a lot with SCEMP, and maths teachers out there, I'm sure, will know their SCEMP and the idea of relational understanding versus instrumental understanding. But basically, what it's about is about maths making sense and maths being coherent. And I think that's what was lacking, like not being able to do. I could do all the stuff, but actually, did it make sense? And did I have an idea of how it all fit together? Probably not, And I remember one of the watershed moments for me, and there've been a few, but one of the watershed moments for me was Marcus de Sotoy did a 4-part series for the BBC called The History of Maths. And as part one, it's about halfway through part one, about 30 odd minutes into part one of the 4 parts, he looked at how Egyptian mathematicians would solve a problem to do with field area. And it's what mathematicians, there are other people out there I know, because I can see who's listening on the show who know this and have seen this as well. But as part of solving that problem, what they did was physically complete the square. And I had to pause the show. I was like, oh my God, that's what completing the square means. That's why it's called that, and that's what that looks like. And it was one of those moments, that you get as a learner, never mind as an educator, that you get as a learner, where it's just like, oh, that makes sense now. And personally, for me, I think that's potentially what's a little bit lacking in, certainly in my experience of maths education and maths teaching and of seeing other teachers teach and things like that. And I think, potentially in the wider sector as a whole, that idea of this stuff should make sense. It's, maths is that one subject that absolutely should make sense. Everything follows logically from one thing to the next. And what I think would improve things potentially for students is obviously having worked like this for a few years, I've got anecdotal evidence that this is the case, but, is actually approaching that subject matter in a way that pupils can see how it builds on the things that came before, not just, that now we're doing non-right trig and before we did right angle trig and that's how it links, but actually they understand that whole journey about trigonometry is coming from similar triangles and everything. And there are lots of journeys like that in maths. And I think if kids see how that makes sense, how that thread follows through in a very coherent way, then potentially we have a lot more people understanding a lot more maths, and we're in a much better situation generally. So that's basically what that was there.
A lot of that chimes with me a lot, Pete, in terms of when I was at school and I learned maths. There were some things that I was taught that you do it like this, but I was never taught why or how or what it actually meant. And that's all what you spoke about in terms of completing the square. It fits in very well with me. It's like when, the quadratic formula and, b squared minus 4ac is that bit, and it's either called the determinant or discriminant, one or the other. I think it's discriminant.
Correct. Well done.
Oh, fantastic! And but I now understood what that actually. I understood that it sort of discriminates between, in terms of how many times it goes through the graph or how many roots it has, whether it has one, none, or two, and whether it's positive or negative or something like that. But I didn't really understand how the formula as a whole worked, and I didn't understand, why it's written like it is and how it all fits together. And there are other things as well, maybe involving some of the calculus at A level and things like that. I just want to say a big good evening to everybody listening live. We've got some fantastic maths teachers listening. We've got Leslie, we've got Atul, we've got Miss Kendall, we've got Sophia, we've got Goldie Tooth, we've got Nizakat Iqbal, we've got the career change teacher as well, ECT in Year 5, and we're going to come on and talk about primary maths in a bit as well. And a very good evening as well to anybody listening back on Spotify, on Apple Podcasts, on our website, ttradio / listen back. And yeah, it's fantastic to be with you here tonight, and it's fantastic to have Pete on. And we're talking about his book, Conceptual Maths, published by Crown House. So you wrote one book, you wrote Visible Maths. Not content with that, you've decided to write another one. Was there always going to be a second book, or was it something you had to think about?
I'm not sure there was always going to be a second book, but I think the sort of idea for the second book came along while I was working on the first. And so for those people who don't know and haven't seen either book, sort of Visible Maths was about models and representation and manipulatives, which I'm glad to say are making their way back into mainstream, even at secondary now. I don't think they ever went away, particularly at primary, but more and more secondary teachers, more and more secondary schools are exploring maths using these things. And again, that was sort of a small part of, let's get this to make sense. How can we show kids this, and kids can see these things in a way that's going to make sense, and using models that are going to go with them through their curriculum journey. So, And people, I know there are, again, people on here who work with these things all the time. And, take, for example, the area model, which is one way of modeling multiplication. It goes through to, when you're multiplying with fractions, when you're multiplying with algebraic terms, when you're multiplying brackets, and this model of multiplication that can be represented as a rectangle and can be built with Cuisenaire rods or with algebra tiles, sort of helped, goes with students through the curriculum and helps them make sense of what's going on, gives them a consistent reference to the concept. But while I was writing that, I was becoming very aware that there was more to say about more things. And, the models and the representations are important. And some of them come into conceptual maths as well, particularly around those number and algebra concepts. But there was more to say about how to get kids to, how to support kids in making sense of some of these ideas. And there were more ideas to talk about, and I wanted to sort of go and do that. So, as I write at the start of Conceptual Maths, it's designed to be a companion to the first book, in that the first book goes really, really deep in models and representations and manipulatives and how you can use those to support kids making sense. And the second book, Conceptual Maths, is broader. That's why it's so much bigger, because it is literally, I think, every school level maths concept. It's not so deep with the models and representations, but it spreads its wings further in terms of, questions you might ask, tasks you might give, things you might draw kids' attention to, ultimately, that give them this awareness of the structure of these concepts and allows them to make sense of these concepts, and also shows teachers where these concepts come back and back and back. I was having a great conversation recently around proportion, and how that comes into so many things that look different on the surface, pie charts, compound measures, ratio, map scales, all of these things, percentage, and very often they're all taught in very, very different ways. But underlying them all is this idea, is this multiplicative relationship, this proportional relationship. And actually, when kids are taught these things as very, very separate things with their own methods, it's very hard for them to get that underlying sense of, actually, these are all part of the same idea. Mm-hmm. And so I wanted to sort of showcase how you can do that, not just with models and manipulatives and representations, but with questions and with things things that you can ask, things that you can draw attention to, that sort of do that for basically every concept in school level maths. So I didn't start writing book one thinking about book two, but the idea for it certainly came along, during the process of writing book one and realizing, there's more to say about more things here.
Yeah, it certainly feels as if they link together quite nicely. And you mentioned manipulatives, of course, in the context of visible maths. Now, this is a bit where my mental model of maths education might fall apart a little bit. But looking at the history of manipulatives is quite interesting, in the sense that about 10 years ago, 11 years ago, Ofsted published a report, Made to Measure, which basically said that primary classrooms could use manipulatives better than they could. And then I believe, this is a bit where I might be wrong, there was an EEF report, and one of the key recommendations about improving the teaching of maths was using representations and manipulatives in the classroom. But then we had a little bit of not a complete reversal, but sort of a warning sign from the Ofsted research review, which I understand was not as universally acclaimed by maths teachers as they have been in other subjects, where Ofsted suggested that the use of manipulatives could become a distraction, and that actually they should be used and scaffolded and taken away over time. Anything you wanted to add on that at all, Pete?
Yeah, well, I won't talk a lot about the Ofsted research review. My opinions on it are a matter of public record, and I don't want to get the conversation sidetracked with that. Nonetheless, there's truth in what you say there, that manipulatives aren't supposed to be something that, and representations aren't supposed to be things that kids go on and use and use and use and keep using and using and using. They're supposed to give that or support that insight into the structure and to make sense of things, so that the transition to the abstract, to working with symbols, is more, is gentler for students, and students can make sense of it and understand what's happening with the symbols. The problem we had, and the problem that potentially we continue to have in certain areas, is you go straight for the symbols, and the kids that can follow it with the symbols, fine, they're the ones that go on and do well. But there's loads and loads of kids that, for that's just a mess of writing on a board with no meaning at all. And then, of course, if you don't make sense of that, then the things that build from that, you're never ever going to make sense of those either. So yeah, I mean, the EEF, your history is pretty much spot on there. The EEF produced a document, I referenced it quite recently, about recommendations for teaching at Key Stage 2 and Key Stage 3, and manipulatives were heavily referenced in there. And I think, what the Ofsted report was potentially trying to get at, although I'm not sure it did it well, was the idea that the wrong model, the wrong manipulative, doesn't actually help kids make sense. And those of us that work with these things all the time know that actually there come points where the model does become a distraction, where the manipulative does become a distraction, because the thing you're trying to model is the thing you're trying to model is so, don't want to say difficult, but it's of a nature that actually the model doesn't really help you with insight into what's going on. And every model reaches points like that, and that's not just to mathematics, that's physics as well. We still teach kids, the Bohr model of the atom, which anybody who's gone beyond sort of GCSE A-level science will know that actually that's a really good model, but it's not really the way that atoms work. But it's a good model for helping make sense until a point, and then we have to do away with it. It's exactly the same with mathematical models. They're most of them are good up to a point. Some of them go further than others, but there comes a point where you have to have transitioned away from it, and hopefully what the model has done there is done enough of a job and supported enough making sense that actually the kids are now fine without the model. And that's always the goal. That's always the goal, for kids to be fine without the model. But of course, what happens when you're only working in the abstract, the kid doesn't get it, kid doesn't remember it. All you can do is go, right, well, let's go over it again in the same way. Let's go over it again in the same way. Whereas if you've got a kid that's sort of edging towards working in the abstract, and then they struggle with a particular thing, so, well, let's go back a step. Let's try and represent this. Let's try and draw this. Let's try and model this and see if we can get a sense of what's going on. And that's the real power with them.
Yeah, no, it's basically like scaffold, in the sense that scaffolding is taken away as well as introduced, I suppose. Now, you mentioned how your book Conceptual Maths covers just about every secondary school maths concept, and therefore I'm led to believe it's 163,000 words.
Give or take, yeah.
Give or take, which is a lot, and I didn't realise this. And when I got my review copy through at the start of this week, and I saw the package it came in, I thought this must be a mistake, and I've got 5 at once or something. But no, it's huge, and you can see it in Pete's profile picture as well. He's holding a copy there, which is much bigger than his head. But yes, it's 163,000 words, give or take. And one of my questions is, do you think there's going to be any maths teachers out there who are going to read it cover to cover? Or is it a book which is just designed to dip in when you need ideas for teaching about a certain topic or a certain concept?
I mean, I hope there are some maths teachers that will be so enthralled with it and so engaged with it that they'll read it cover to cover. But I think in terms of use, it is probably more towards that second one. I think the only danger with the approach of dipping in and out of it is that there's the potential to lose that thread. We're talking about, making maths coherent, making maths make sense. And if you just look at, I'm teaching speed now, let's see what Pete has to say about speed. Or if I'm teaching manipulating algebraic fractions now, let's have a read of what Pete has to say about that. Well, what people have got to be aware of there is that, when you're talking about speed, the sort of things that I say about speed don't really help kids and don't really help teachers unless the stuff before it has also been put in place. So my best advice, because it is a huge book, and I'm not going to say that people should read it all the way through cover to cover. My best advice would probably be for those teachers that are not going to read it cover to cover, is to take it a chapter at a time. I think each chapter summarizes nicely some really important ideas, and I think if you take a chapter at a time and you get a sense of what that chapter is saying, then you've got the building blocks there to go, right, so this comes from this and this leads to this, and actually I need to start with this here, like this, or ask these sorts of things to build them up to this bit. And I think if teachers did that, that's if you're not going to read the whole thing cover to cover, then that's probably the way that they would get best use from it.
And so you do mitigate this, don't you, in terms of the design of a book and the designs of the chapters, in that you talk about prerequisites a lot, and you mentioned these a lot at the start of every chapter, in that the sense of particularly the later chapters, if you're teaching this, you need to make sure that students are comfortable with this and this. And did that inform sort of how you sequenced the concepts and the topics throughout the book, in the sense that, starting with number and ending with charts and data and graphing, was that sequence of sort of how you'd introduce everything driven by this idea of prerequisites, or did you sort of grapple with how you would sequence them in the chapters in your book?
I mean, yes, to an extent, but as anybody who's got into the early part of it knows, it's actually pretty impossible to sort of create a linear model for how that sort of journey goes. That journey isn't linear. There are aspects of a concept that you need to study, and then you need to put them down for a bit and study an aspect of a different concept, and then, suddenly they magically appear together at a later point. So, I try to structure it partly in terms of number is clearly a really important prerequisite concept for a lot of things, as are the basic operations and things like that. But, I'm not saying that we should be teaching probability and chance and graphing right at the end of a journey. There are bits of that are going to pop up through, a student's school journey from year one or EYFS all the way up to year 11 and potentially beyond if they go beyond. So you can't, it's not that linear sort of thing, which is why, literally with every concept, we talk about where the prerequisites are so people can go and find them. It's at the start of chapters where we introduce the first part of the concept, but it keeps coming back through the chapters when when we meet a new concept within that. And then I suppose the other sort of structural idea there was to group topics together, and I use the word topics, and as I say in the book, it's really hard to actually say what we mean by that mathematically, because there are some of these things that you could be teaching here, you could be teaching here. I mentioned proportion earlier. You could be teaching pie charts when you're teaching proportion because it's a proportional representation, or you could be teaching pie charts when you're working with data because it's generally used to represent data. So, where you teach those things is kind of up to the curriculum you want to put together. But I try to group them broadly into similar topic areas. So we start with sort of, your number, your basic operations, going in that sort of direction. And then we transition through to proportionality and functionality. And then we tackle, the stuff around shape and measure and things like that. And then we sort of conclude with the statistical and probability side of things. But it's not a linear journey, and I don't know anybody I don't think it's even possible to put those things on a linear journey. But it is sort of, there are potentially more fundamental things towards the beginning, things that are prerequisite for more of the other stuff, but also they're sort of just grouped into broadly similar areas, I think, is the sort of main design structure of the book.
Oh, thank you for that. And we'll talk about that a bit more in a second. I just want to say, if you want to take part in the conversation, if you want to ask Pete about conceptual maths, in the bottom right of your screen, there's a speech bubble, and you can use that to tweet in. Also, more than welcome to take any callers, particularly maths teachers who want to talk about conceptual maths or ask any questions of Pete as well. All you have to do is in the bottom left of your screen, there is a request to speak button. You can press it there. If you're listening back on our website or on Spotify or on Apple Podcasts or on our Twitter, on the Twitter space directly, then you can tweet us at TT Radio Official. You can tweet Pete at Mr. Mattock, and you can get involved, ask questions, tell us what you like about the book, and you can do that during the show now, or you can do it after the show. The Twitter space will be available on Twitter for the next 30 days, and it will also be published as a podcast on our website as well. Is it so? You talk about how maths it's not a linear subject at all. Is it too simplistic to say that a lot of maths curriculum design follows sort of a spiral approach?
No, I don't think it's too simplistic. I think, spiral or cyclical curricula are relatively common. They're not the only curriculum model out there, obviously, but I think, they have that advantage that you sort of explore an idea and then you explore a different idea and then you come back to the earlier idea, perhaps in conjunction and things like that. So I think, no matter how you structure your curriculum, you are going to be returning to ideas that you looked at before. So yeah, no, I don't think it is that. I think, in terms of mathematics, it's definitely hierarchical in nature, in terms of there are certain things that you have to look at before you can look at other things. But that's not a linear hierarchy. And in fact, one of the best diagrams out there is something that LaSalle put together, LaSalle Education, that is. And they have this diagram that shows sort of key learning points. They're not concepts, but key learning points about school level maths and how they connect and things like that. And it's a huge diagram, 3D in nature. And that sort of shows the complexity around it. But yeah, no, I mean, however your curriculum design goes, ultimately, you are going to be coming back to concepts you previously studied and looking at them in the new light or combining them with new things. Whether you as a cyclic curriculum, have to revisit the same thing in the same way that you've done before. And you see that. You see, we teach kids to add fractions in year 8, and then we'll do it again in year 9. Well, I mean, okay, yeah, but if you secured it in year 8, why would you have to go and do it again in year 9? Particularly if you've been using it, sort of continually coming back to it all the way through. But yeah, no, spiral curriculum, I think, and it is fairly common, and it will help you capture those places where you need to come back and revisit concepts in new circumstances and in new lights.
Mm-hmm. Now, you see, as a history teacher, the idea of a spiral curriculum and hierarchical knowledge and things like that is quite alien to us in that sense. And in the sense that history curriculum design and maths and science curriculum design is so incredibly different in many ways. Let's see who else we've got. We've got Andre, who has joined as well. Very good evening. We've got Catherine as well. Very good evening in the studio live. You've talked about prerequisites. You've talked about how things fit into this bigger picture, not just in terms of where things come from, but also in your book you talk about what it leads to and the ideas that this leads to, and how the stuff which is visited in the book then acts as a prerequisite for other stuff. Do students need to understand this idea of this bigger picture of how it all links in, or is it in? And do students need to be able to articulate this, or is this something that actually is sufficient? So long as the teachers know where it all fits in, and so long as the students are learning it, then actually that's sufficient. Or do students need to be able to understand this and articulate this?
I mean, I definitely think students need to be able to understand it, and I think that that's one of the major points, is that if students ultimately leave a mathematical education at 16 and don't do any further, explicit mathematical education. I mean, I think that, that's a maths is part of a lot of subjects, and they will use mathematical ideas in a lot of subjects, no matter what they go on to do. But if they're not explicitly being taught maths beyond 16, and they leave maths at 16 without this idea that, these things are all connected, they're all part of a bigger whole, and the things I studied here are linked to the things I've studied here, like this and things like that, that actually they probably don't know an awful lot about maths at that point if they can't do that. And if they don't understand that and they don't recognize that. So, and I think, that's the main purpose of conceptual maths is yes, teachers need to understand that, but they need to understand that so that they can effectively communicate it to pupils. In terms of articulation, I mean, I think they need to be able to self-articulate. They need to be able to articulate it to themselves. I don't think there's anybody else that they need to be able to say this is this and this is this too. I think it's important that, in their own words and in their own way, they've been able to, I keep coming back to the phrase, but it is probably the most important phrase that I use. They need to be able to make sense of that journey that they've been on and those ideas that they've encountered and how they link to each other and how they connect to each other for themselves. So, I wouldn't be asking students necessarily to articulate that and use the same language I would use, but it would be important that they can articulate it for themselves and say, this is what it means to me, and this is what I've noticed and recognised and understood from that journey. And I think if they leave mathematics, at 16 or at 18 or whenever they do, without a sense of that, and this is what a lot of students do end up doing, leaving without that sense. And one of the biggest detractions that we get about mathematics education is it's a lot of facts, it's a lot of memorization, it's a lot of formulae, and I've just got to remember all of these multitude of things and wheel them out at the right time. Well, that's the problem for me, is that actually that multitude of things probably doesn't need to be that huge, because several of them arise from the same idea. And actually, if you had a good understanding of the structure of that idea, you would be able to apply it much more effectively to this, and this, and that would help with, the few bits that you do have to remember and you do have to memorize, because there are some things, but yeah, I've lost the thread I was talking about there. So yeah, it's definitely something that students should be aware of. We should be making that explicit in whichever way that we want to make that explicit. And I'm not here to talk about, the pedagogies that people should employ. That's up to them and their context. But what we should be aiming to do, absolutely, for me, is make sure that students understand that maths, there's this thing called maths that maybe has these different concepts within it, but there's connections here, and there's things that might look very different on the surface are actually all part of a deeper underlying idea. And I absolutely think that students should leave education understanding that and being able to self-articulate it.
And that's certainly helped by the ideas in your book and how it all pieces together, and makes many parts into a whole and things like that. And that's what, flicking through your book, that's what it does so well. Do you think, though, that students are leaving schools at the age of 16 with this in place? Given, I don't know what the most common exam board is for GCSE maths, but I'm looking at the Excel grade boundaries here, and you only need 57% to get grade 7. And now a lot of sixth forms that I've looked at, one of their prerequisites for A-level maths is a grade 7 in maths, but that's still getting more than 2/5 of a paper wrong. So do you think that students are really leaving school at the moment with this conceptual idea of maths in place?
Probably not as widely as they should be, and that's one of the motivations for putting a book like this out there and for doing the work that I do around the circuit in conferences and things like that. Because one of the things I will say to teachers all the time is, forget the grade 7 there is, as you said, is just over 50%, and what's really shocking to me is that only 1 in 5 kids actually get that. Give or take, depending on the year, only 1 in 5 kids actually get that. So, 750,000. And I think, not wanting to name drop different exam boards here, but I think, the lion's share of it is potentially EdExcel, although obviously AQA and OCR and WJC or Educash in England get their bits as well. But on all of those papers, the grade boundaries are relatively similar, and on all of those, it's roughly 1 in 5 kids. So what we're doing here is basically putting kids through 16 years of maths education, and only 1 in 5 of them pop out even being able to meet that threshold, which, as you've identified, is not actually that high. I mean, like I said before, the new GCSE is much more challenging than the old one, and rightly so. But the threshold for being in that top 20% is only, say, between 50 and 60% on the exam series. So, and I can't hold my hands up and say I've done better than that. I mean, I maybe up to a quarter or something like that in the schools that I've worked in. But I can't say I've done better than that because, it requires that something fundamental to change in that 16-year journey before we are going to get better than that. But I think the fundamental thing that needs to change is, like I say, actually kids learning about mathematical ideas and understanding these concepts and being able to see them again and, saying, oh, yeah, I know that. That's just like when we did this, or that's that. We should hear that a lot in maths classrooms, and I don't think we hear it as much as we perhaps should. So, yeah, I mean, in terms of are they getting that, I think the evidence is quite clear that that's not really happening for the vast majority of students, but it is going to need something fundamental to change across the entire age range from 5 years old up to 16 years old to do that. And, we're making the right noises, potentially. The NCTM and their work around teaching for mastery has got some good bits and pieces in there. But there's probably more that still needs to happen in terms of systemic change for that to really become a reality.
Yeah, I think it's absolutely remarkable that based on what you've said and based on what I've seen, that 4/5 of students at the age of 16 are finishing, are leaving school and they've got half of their GCSE maths paper wrong. I think it's remarkable, and it reminds me.
Well, it's not quite like that because obviously the kids that do the foundation paper will be getting a lot more than that. But of course, the kids that are doing the foundation paper are not, not even taking that journey as far as they could, in effect. So yeah, it's a little bit more complicated than that. But ultimately, bottom line, what 80% of kids cannot do is open a higher paper and get beyond halfway. In effect, they don't understand enough maths to do that. They can't apply enough maths to do that.
No, thank you for the clarification. They're very important. And yeah, you mentioned as well teaching for mastery, and we spoke earlier on in the show about this difference between, say, procedural maths and conceptual maths, and the differences and the similarities between them. For those people who aren't maths teachers like me, who hear these ideas about teaching for mastery and things like that, what is teaching for mastery in maths, and how similar is it to conceptual maths?
Oh, we're opening up a big can of worms here, Tom. I can tell you, because mastery.
I want you to take up most of it.
Sorry, say that again.
We've got 47 minutes left, and I've got a few more questions after the mastery.
Yeah, no, that's fine. I'll try and be succinct. So yeah, I mean, the one of the things with mastery is it does mean different things to different people, and that's potentially a problem. So, in terms of the NCTM and teaching for mastery, what that's about basically are some good practices that should enable students to develop a sort of procedural understanding alongside a conceptual understanding. And let's be clear, nobody's saying that procedural understanding isn't important. Kids have got to be able to select calculation strategies. They've got to be able to solve problems. They've got to be able to sort of run processes through in an efficient way. The point here is that if that's all they can do, then that's not a lot, So what the Teaching for Mastery about, certainly in terms of what the NCTM says, and I don't want to talk for them because although I have done work for them up until very, very recently, I'm not now, part of what they do. But what it's about ultimately is it's some good things to think about for teachers that should enable that further depth of development of understanding around concepts as well as the procedures at the same time. One of the fundamental things they talk about is that coherent journey. They look at representation, they look at something called variation theory, which we definitely don't have time to go into in any great detail. And mathematical thinking and fluency, which is different to automaticity. It's being able to use those ideas flexibly and spot when those ideas are going to be used. So, there is like I said earlier, there is definitely some good stuff from that, but what potentially needs more. We probably need more in that area. We probably need more structure for teachers in that area in terms of, yes, we can approach these concepts coherently, but what does that look like more widely? And I think conceptual maths is potentially the start of that. But I think it's, we've still got work to do as a sector to sort of embed those ideas.
Yes, I mean, if you mentioned mastery to our maths department in my school, you can't shut them up for about an hour talking about mastery and all of the sort of implications and all of the challenges and all of the strengths of it as well. And so, yeah, I find this all very fascinating. And one of the things which I wanted to talk about as well, regarding conceptual maths, but also linking to the processes and how these link together, is this idea of having multiple methods. If you have a student who has got, one method of, doing multiplication of integers or something, and they're very comfortable with that method, but then as a maths teacher you try to introduce a couple of other methods and you try to show them sorts of multiple methods of tackling problems, how important is it that to teach multiple methods for tackling problems when students in maths classrooms may actually just prefer to use just one?
So, I mean, I think there's a couple of things to say about that, and that is that first of all, the method is the wrong place to start. And anybody who introduces a concept with a method to do things in that concept, that's where ultimately the problems lie. So, I mean, let's take column multiplication as a prime example. That's a process that many kids are familiar with. Many kids can carry out. It's the agreed algorithm, if you like, for Key Stage 2 stats, where I'm not sure if you're aware, Tom, but I know that there'll be maths teacher listeners who are aware. If they don't use that method, then they don't get the method marks in the sats. If they get the answer right, they can use whatever method they like and get marks. But if they get the answer wrong, they'll only get method marks if they use that particular method. But I think the important thing there is if you're starting an exploration of multiplication with, there's this thing called a column multiplication algorithm, and this is how it allows us to multiply big numbers, then we're starting sort of a bit late on. What we need to be understanding first is, what does it mean to multiply? What does that look like? How do I make sense of this idea called multiplication? And there are multiple different ways that we can think about multiplication. There is repeated addition. I've mentioned areas. There is scaling. There is unitization. Most of this actually is invisible maths, not conceptual maths for multiplication. But there are things like that in conceptual maths as well. So, yes, we might sort of look at different ways of thinking about multiplication, and one of those may lead us towards the column multiplication algorithm. But then, how important is it to then go to other methods? Well, if we're looking at different ways of making sense of multiplication, then, well, where do they lead? What does that tell us about how I might calculate some stuff? And one of those, the area model, leads into the grid method of multiplication, which in terms of a model the area model and being able to represent multiplications as an area and then as a grid is generally speaking a model with much more longevity. Like I say, it's much easier to make sense of later multiplications when you're multiplying things like fractions, when you're multiplying things like algebraic terms, when you're multiplying or expanding brackets. The area model is a much more flexible model for those scenarios than anything that leads towards the column multiplication algorithm. And I think as well that if you've only got the one method, then you've only got, so that was the first point. The second point is if you only got the one method, then when there are times when that method is inefficient, you're in a bit of trouble. And, one of my favorite examples here is calculate. It's not multiplication, it's subtraction. If I ask kids to calculate 3002 subtract 2999, and I ask kids to do that in year 7, and they dutifully write out 3002 subtract 2999 in columns, and they do that subtraction, and some of them will get that wrong. And it's not because they don't know how to do column subtraction, it's because of the amount of exchanging that's involved there. You have to borrow from the 3000, not borrow. You have, we can call it borrow. But you have to, exchange your 3000 for some hundreds, and then go. And kids just mess up. They make mistakes there, and you look at that and you think, how has a kid got to year 7 and not recognise that 3002 minus 2999 is a difference of 3, which is fundamentally a different way of thinking about subtraction than the takeaway model that the subtraction algorithm uses. And if they don't see those different ways of making sense, then those strategies that they can choose to employ at different scenarios just aren't there. They're not there for use at all. And that's where kids start to fall behind and struggle. And so, in terms of how important it is, it's really, really important, because each of these procedures that we might employ links to different ways that we might make sense of things. And we are going to need those different ways of making sense of things if we are going to package that as a whole learning maths and the journey of learning maths. So, yeah, really, really important, because what we want kids to do is not be pinned to one method. It's to select the appropriate method for the situation they are in.
The reason why I asked that question was because just before I broke up for half term, I sat in our staff room with one of our other history teachers and one of our geography teachers, who each, due to timetabling pressures and due to the fact that they have A levels in maths, teach half a year 7 class each. And they'd got onto a bit of a curriculum which was dividing fractions by fractions. And as any kid in the country, if you said the word letters KFC to them, first thing they'll think about is chicken, and the second thing they'll say is keep flip change. But they were going to teach this lesson on the bar model of dividing fractions, and I sat in this staff room with them for I was out the door, and then 35 minutes later I was still there, and I was trying to decipher this in terms of how on earth do you use these bars to divide 1/3 by 2/5 or something. It's like, how many thirds can you get into 2/5? Draw these bars, etc. I couldn't understand it, and I felt so fortunate that I wasn't the one who'd made my A level in maths public knowledge and therefore had to teach this. And now that I'm hosting a radio show on it, it now is public, and therefore I'll probably have a year 7 class next year. But can you please, because I'm going to be sharing this with my maths department once we've published the interview, and I just want a really simple and not simple because it's not simple, but a concise and effective and efficient way of just explaining how I would divide 1/3 by 2/5 using that bar model way of thinking about it.
Okay, well, I mean, to do that without an image is quite challenging. So what I'll do,
an image, but if you could sort of, because I can sort of picture the image, I can picture the squares, and I can picture where I might have to draw the bars or something. So, but any wonderful. I know that your book, Conceptual Maths, relies so much on these images and making it really crystal clear. So, any descriptive language you can use would be most beneficial.
Yeah, no, that's fine. So, I mean, the first thing I will do is say, yes, I'll go through that, but I will also point you and any other listeners to my YouTube channel, because division of fractions using Cuisenaire, which are sort of a physical manipulative bar model, is in there. And you can actually see it happening. You can see it go alongside. So in order to really get at that with you, I need you to understand that there's a model of division which is about comparison. So when we talk about, as a simple example, 6 divided by 2, yeah, let's start with that. We can think about that as splitting 6 into 2 equal pieces. We can think about that as having 6 and creating groups of 2.
Mm-hmm.
Or we can think about it in terms of, how does 6 compare to 2 in a multiplicative sense? How many times bigger is 6 than 2?
Mm-hmm.
And the answer to that, of course, is 3 times bigger. And one of the key questions that comes alongside that is, and it's one of my favorite questions in all of mathematics, and it's with division, is what if this was 1? So imagine a bar that was 6 squares long, and then imagine a bar underneath it that was 2 squares long, and then imagine me asking the question, what if that thing that's 2 squares long is what we now call 1? So that's now the number 1. How big would the thing above be? Yeah, and the thing
carry on.
Yeah, so the thing above would obviously be 3. Now, ultimately, the same model works for division of fractions. So you talked about a third divided by 2/5. Now, in order to look at that division as a bar model, what you've got to be clear on, and this is one of the things we're not good at in this country when it comes to fractions. And again, I know there are some listeners on there, hi Atul, that have heard me talk about this before. But one of the things we're not good at in this country is making clear the fractional relationship to 1. Yeah, so we talk about fractions in terms of splitting the whole, but when you've got a third of a whole, you've got a third of that whole, and that whole could be worth anything. If that whole's worth 10, you've got a third of 10. If that whole's worth 30, you've got a third of 30. To actually get the number 1/3, you've got to be talking about that in relation to 1. So the first step in representing fractions, particularly 2 fractions with different denominators using bars, is, well, actually, how big is my 1? What does 1 look like in this scenario? And obviously, if we're talking about thirds and fifths, then the 1 is going to need to be something that I can divide into 3 equal pieces, because otherwise I can't get thirds. And I also need to be able to divide it into 5 equal pieces, or I can't get fifths.
Yes, I've just realised I could have given you 2 better denominators for this.
No, it's fine. It's perfectly good. So if we're thinking about a number that I can third and I can fifth, then the obvious candidate, hopefully you'll agree, Tom, is 15.
Yes.
Yeah. So what I want you to picture is, I want you to picture a bar that is 15 squares long, and that bar represents 1. And so now that we've got that 1, above that, we can think about what would 2/5 would look like. Well, if 15 squares represents 1, then obviously 1/5 would be 3 squares, and so 2/5 would be 6 squares. Yeah. So we've got a bar above that that's 6 squares long that represents 2/5.
Yeah.
And then our third will be, right, well, if we're talking about if our 1 is 15 squares long, then a third is 5 squares.
Yes.
Yeah. So what we've got is that picture of a bar with 5 squares, and then a bar with 6 squares representing the third and the 2/5.
Mm-hmm.
And then we've got a bar underneath that, which is 15, representing 1. Okay. And then what I want you to imagine is that we rub out that bar of 15.
Yep. Done it now.
And we change the bar that was 6 so that we now call that 1. And again, that's that same question. What if this was now 1? And so what fraction of that do we have in the top bar? Well, we had 5 squares. Our 1 is now 6 squares. And so the result of that division is 5/6.
Yes, I can see it very clearly on my piece of paper that I'll tweet out later.
Yeah, and that's exactly what you get if you do keep flip change. You do 1/3 divided by 2/5 becomes 1/3 times 5 halves. and that becomes 5/6.
Yeah.
So that's the way that sort of model leads to that. And in fact, it really nicely, that model that I've just talked about, because there are other ways of modeling that, but that model that I've just talked about really leads nicely into why you multiply by the reciprocal, which is my preferred way of talking about that, rather than keep flip change. I'm doing a third multiplied by the reciprocal of 2/5, because actually it's multiplied by the reciprocal that makes 1. That's what the nature of the reciprocal is. If you want to turn 2/5 into 1, you multiply it by 5/2. That's what you do. And so actually, by turning that 2/5 into 1, by multiplying by 5/2, you also have to multiply the third by 5/2 as well. And that's where that sort of idea sort of comes full circle into the abstract. But yeah, say for anybody that didn't follow that, it's on my YouTube video. Very similar example, actually.
Yeah.
It's on my YouTube video, and you can hear me narrate that with the bars actually doing that and the calculation being written alongside.
Yeah, but a visual. But no, I drew out exactly what you did there, and I thought it was, and very well explained, and much better than I managed in that 45 minutes of my life I'll never get back. On a night, somewhere in deepest, darkest, rainy Nottinghamshire. I should point out that Pete's book is published by Crown House, and we've had some shows from Crown with other Crown House authors as well, which I want to talk about. Just before me, he's in the studio now with Nathan Ginn. I mentioned it at the start of the show, but he was talking to Eddie Costello, talking about square pegs. And those students who just don't fit into our educational system for one reason or another, and talking about persistent absence and ways in which we can actually empower students and get them in our classrooms and get them learning. We also, back on the 3rd of February, we had a show with John Gibbs. He was talking to Colin Diamond and was talking about the Birmingham book and lessons in urban education policy for the Trojan Horse Affair, which is somebody who's fascinated in these sorts of things as a history teacher and a social sciences teacher. It was a really, really good show as well. We've also got some shows coming up in the future as well with Crown House. So we've got 2 shows with Graham Stanley, we've got Christian Steele, and they're going to be talking about test enhanced learning, which I'm really looking forward to. And Camilla Gita Hughes is going to be talking about the Mindful Teachers Handbook. And one which I'm really looking forward to, it will be on Twitter Spaces on a Thursday evening, just like this show, with Hannah Wilson. She's got Toria Bono on, and they're going to be talking about her book, Tiny Voices Talk. So we've got some fantastic shows coming up with Crown House as well. But we're here at the moment, we're talking to Pete Mattock, we're talking about his book, Conceptual Maths, which is fantastic. And we've been talking about how we teach maths conceptually, and why this means that we need to be teaching about mathematics rather than just how to do it. I should also point out that your book is available on Kindle. If you don't fancy lugging about all 163,000 words and their weight with you, that you can get a Kindle version. And I just wanted to ask you about how your book would support particular teachers in particular stages of their careers or in particular settings. And I wanted to talk about primary teachers, because some primary teachers, Pete, would look at your book and go, oh, surds, I don't know what a surd is. But they'll find other parts of the book useful as well, and they'll find most of it useful, in fact. So how does your book support those primary teachers, particularly those who might not be as confident with their maths teaching as primary maths specialists or secondary maths teachers?
Yeah, I mean, really good question, actually, Tom, because, there's 2 parts to that. And the first one is, when I say every school level concept, I mean every school level concept. We're not just talking the secondary school level concepts. We're talking about the very basic concepts and the foundational concepts that are introduced at primary level at year 1 in EYFS. So, the first part of the chapter in number talks about the transition that pupils make. It doesn't talk in great detail because it's not my personal specialism, but it talks about and recognizes that the transition that kids need to make from one-to-one representation, which is, which comes in 2 parts. It's when I talk about one toy, say, I actually see one toy. But then if I talk about one apple, I see one apple. And having that context combine with the mathematics to a point where there's a transition that kids need to make, where they transition to, I can think about one toy and I can think about one apple, but I can represent it using this counter or this tile or this bead on a reckon or abacus or something like that. And that's a transition that happens really, really early on. And it's definitely a transition, that there are lots of excellent primary practitioners out there and early years practitioners and year one practitioners that will be able to talk a lot more intelligently about it than I can. And then there's a second transition, which is that one-to-many transition, which is actually when I see one object, I'm aware that it could be worth something other than one. And that's normally done, with things like Dinesh blocks and 10 frames and things like that, where you put your 10 counters into a frame or maybe Numicon, and so you've got you can see the 10 at the same time as being able to treat it as a single object. And eventually you transition into something like place value counters, where you can you have a counter that's simply worth 10. And obviously, of course, money is like that. You transition into money, where this one object is worth 50 times greater than this object, if you're talking about a 1 pence piece and a 50 pence piece and stuff like that. So, primary, the maths of the primary curriculum is definitely catered for within that book. But you're right, it does go all the way through school level, so it goes to secondary. But I think the other thing that is really, really important is both primary and secondary maths teachers understanding where the maths they're teaching leads and where it comes from. And when we talked earlier about systemic things that need to change, for this idea that kids are going to go on a journey with maths and understand these threads that they pick up and put down and then come back and weave into this narrative, it's going to be really, really important that primary maths teachers understand that the maths they're teaching now and the way that they're teaching it is going to influence this, and this at secondary level. And similarly, it's really important that secondary teachers understand that the maths I'm teaching now builds on and comes from this, and this, and this that they would have explored at primary school, and to have an understanding of what pupils' experiences might have been at that level, so that they can help weave that next part of the narrative, that next part of the tapestry, together for pupils and help pupils to see that next part. So, that's why it is literally every school level concept, because I think anybody that teaches maths, and I know it's a big ask, and it's more of an ask for primary teachers than it is for secondary teachers, because secondary teachers, with the exception of the non-specialists, like you've talked about, only really need to worry about their subject. Whereas primary teachers need to worry about every subject. That is not an easy thing to do. And my hat goes off to all of them for being able to do that. But I think it's really important for everybody that's teaching maths to have some understanding of where that bit of maths that you're teaching goes and how you can set the kids up with what you're doing now in a way that is going to allow them to continue to make sense of that as it progresses through the curriculum. And so that's why I would be saying, what would be saying to primary teachers is, yes, you will find things in there. You will find representation, you will find questions, you will find tasks that are going to be suitable for the kids that you're working with now. But one of the really big reasons that they are going to be suitable is because they lay the foundation for where kids are going to go with it in a way that's going to allow them to sort of access that tapestry and to weave that narrative together over time.
Yeah, I think the point you make there about how primary transitions into secondary, etc., I think that's really, really important. It's certainly not one which is limited to maths. As a history department, we are always very keen to know what history has been taught in primary schools. And I suppose the difference between maths and history, although it may be an oversimplification, is that the maths that is taught in primary schools, there's very little difference in terms of what maths is taught when differences in terms of how it's taught, but in terms of what maths is taught, ultimately it must be very similar. Whereas in history, we have some students who've come in who've studied all sorts of different events. We've got some students who've studied Martin Luther King. We've got some students who've studied the Romans or the Aztecs or the Incas, or I don't know. They've almost all of them have done Victorian Britain or the Blitz and sort of the Home Front and stuff like that. But we've got that huge variation in terms of sort of the concepts within history in terms of substantive concepts. Whereas I suppose with maths, it's much more, similar in terms of what is being taught, and therefore a book like Conceptual Maths is very useful as a companion, as a guide for somebody thinking about that transition, right?
Yeah, I think that's absolutely fair. Is that the maths curriculum is very prescriptive, primary and secondary, in terms of what mathematics kids should encounter. It's a lot less prescriptive about how they should encounter it. And that's where we get that variation, and that's where some kids will encounter mathematical ideas in a way that allows secondary teachers to build on them, and some kids will encounter mathematical ideas that in a way that is very, again, to borrow Skemp's language, very instrumental, and that potentially has embedded some misconceptions, and that you would need to begin to unpick. But I think that's quite a reasonable way of putting that, Tom. I think you're right on that regard.
And I want to talk, because we talk about primary teachers there, but I want to talk about, and this is just a completely hypothetical example of somebody who's, straight A star, straight grade 9 in maths at school, at GCSE at A level, gone to do a 3-year degree in maths, has, and university maths, I wouldn't understand it as maths. I'd just look at it and go, what on earth is going on there? And they've done that. They've done a 3-year undergraduate degree in maths. They've got a first, first in every unit, let's say. And they decide, with all of my wisdom and all of my knowledge of maths, I reckon I can go and teach in a secondary school. And they do, because actually teaching is a fantastic career. And they turn up on their PGCE or their SCIT course or whatever, and they're given their first timetable, and they're given, let's say, because maths sets a lot, almost every maths department must set, but then they're given bottom set year 9 to teach, and they don't understand, as a trainee teacher, or as a ECT, or as any teacher, I suppose, they don't understand what these students in front of them know and don't know, and they don't understand that they can't sort of empathize, and they can't put themselves in that student's shoes. They assume that things that must be obvious and they must get, that actually these students don't understand. How can your book support somebody in that very sort of extreme and over-exaggerated position? How can conceptual maths support somebody in that position to actually make maths clear and actually teach about maths to students who actually they may not be able to understand what's going on in their minds?
Yeah, so I think there's a couple of different ways that it would support teachers like that. I mean, I think one we've talked about already, which in terms of the prerequisites. So, if you've got a bottom set year 9, say, and you're trying to teach them about Pythagoras' theorem, which you shouldn't be doing with a bottom set year 9 if they don't have the prerequisites anyway. And they're really struggling to get this, and how can they be struggling to get this? Well, I mean, they're probably struggling to get it because actually, there are things that are prerequisite that they don't get and that they don't have, that they've not connected into their, to borrow language from cognitive science, their schema. So, and that would be that potentially things like, well, actually, the area of a square. If they don't really understand how squaring gives the area of that square, assuming you are going to teach with some form of representation and not just try and tackle it in the abstract anyway. So it can highlight to you where the prerequisites are, so you can go and have a look at those and say, right, well, actually, I need to establish first which of these gaps is missing. And that, you've got to do that with kids in maths. there's no good, and Mark McCourt talks about this a lot, there's no good employing that sort of conveyor belt curriculum where, right, a time to do that is finished, so now we're going to do this. But if this is built on that, and whether whether the time for it is finished or not, if they haven't got that, if they don't understand that, then doing this is fruitless, because of course they're not. How can you expect them to get it? How can you expect them to reach that level of understanding you want? Because the thing before it wasn't secure. So it can highlight the prerequisites, and it can show them, I potentially need to assess where kids are with these things first, and then look at which of those I might need to re-explore before I then go on and look at this idea with them that I want to look at. It can obviously support them in terms of making that maths more visible to them. And again, visible maths would be the main one to do that, but not with Pythagoras' theorem, because I don't cover it in visible maths. But making that maths more accessible to them, more visual to them, so that they can actually make sense of it. They can see what's happening. They can reach that understanding. Because it's not just a bunch of squiggles on a page, which is what maths looks like to some kids. Oh, that's just a bunch of symbols that when these symbols come in this order, it means this. So it can help them in that regard as well, and it can help them with, like I say, one of the big things I did want to put in here is questions and tasks that draw attention to the right things. And there's a lot of practice that goes on in maths. And when I talk about practice, I don't necessarily mean teaching practice now. I mean things that we actually do get kids to do, and we get exercises that we give kids to do, which is not necessarily drawing attention to the things that we want it to draw attention to. And so there are tasks in there that are really, really good for... And they're not necessarily my tasks. Some of them are, but I borrowed them from huge amounts of different places. So some great maths educators out there that come up with some wonderful tasks that I borrowed and, with their permission, published, so that everybody that reads the book can see them. But there are tasks in there that they could be asking students to do, or questions that they could be asking of students, that will potentially help draw those kids' attention to the things that they really do need to have their attention drawn to in order to understand that idea. So I think those would be the main ways that a book like Conceptual Maths would help a teacher in that scenario.
Thank you for that. And I should point out, of course, that if you are a mentor of a trainee teacher, or if you're a head of maths and you want to buy a copy of Conceptual Maths for your department, or a couple of copies, or one for every teacher, that you can get a copy. Tom Rogers has very kindly pinned a tweet to the top of his Twitter space, if you're listening live, from Crown House, where you can actually buy Conceptual Maths with free UK shipping at crownhouse.co.uk. That's crownhouse.co.uk if you're listening back and you can't see the pinned tweet. I think it's really important to actually, this is a book that can support teachers at completely different stages, and actually also those teachers who may have been teaching maths for 20 or 30 years, who have gone, well, this is how I've always done it, and might potentially turn up their nose at new ways of thinking of maths, and actually the way of actually breaking down concepts and going back to first principles in some cases, I think, is really important as well. Because the book is Conceptual Maths and it's all about concepts, I want to know what other concepts that, let's say, secondary teachers of maths struggle to teach the most in your experience. Is it stuff like constructions, or is it just that the kids don't like those? Is it something else? What are those concepts that teachers in maths departments go, oh, I really don't like teaching that, the kids just don't seem to get it, or even worse, oh, I just don't know how to explain it really clearly? Are there any concepts in maths that really stand out in that regard?
There are a few, but they're very different for different teachers. And, it's always one of the fun things. We get it come round every couple of years, the poll, which of these things do you like teaching the most? Which of these things do you like teaching the least? And you've mentioned one of them. Constructions is one that's on there. And, I always, in fact, constructions is probably the most sort of reference one in terms of when people are talking about what could come off the maths curriculum. Most people go for pencil, ruler, and compass constructions. Something that's very antiquated and blah, blah, blah. But the point I always make with something like that is, well, yes, it is. But what it is a new way of looking at shape properties. And the properties of shapes, diagonals and angles and sides and things like that. And those are really fundamental things. What makes a square? Well, it has these properties, and actually constructions gives you a new vehicle into that. It also links really nicely with inequalities of regions, because when you're drawing loci, what you are in effect doing is drawing an inequality, a region for an inequality that people used to do before we had the language of algebra, where we could express those inequalities algebraically. So it links really nicely into things like that, and into graphical work. We don't teach it in the secondary curriculum, but the parabola, which most people know as the x-square graph, started life as a construction. It is the locus of all points that are equidistant from a point and a line. So, there are loads of different, and this is what I mean, and this is why I think conceptual maths was so important for me, is because these sorts of links are not things that that people will have necessarily come across, will necessarily appreciate. I remember talking a long time ago with a group of people and saying, this is all great, but where do we get the time to actually do this thinking? And that was one of the things that stuck with me. Maths teachers don't have time to do this thinking. So what I'm trying to do is help support that by saying, well, here's some of my thinking along these lines. And I have, made time to sit and think about these things. So just use that as a start point. Use that as a way to get your own brain going with it. Coming back to your original question, which I'm aware I'm not answering, constructions is definitely in there. People, I think, not necessarily that they not enjoy teaching, but I think that potentially that they don't teach in a way that links with this is stuff like averages and the measures that we use for average. It's not necessarily one that's often quoted in terms of things they don't like teaching, or things that people feel like they teach well. But actually, a lot of that is very instrumental in nature. You ask many kids. I would venture the vast majority of kids what mean is, and the vast majority of adults potentially, at least those that remember it at all, and they're going to tell you, oh, it's where you add them all up and divide by how many there are.
Yeah.
And that's, I haven't got time, I don't think, to go into all the things that are wrong with that. Can you still hear me? Because I've got a thing on here that says connecting.
We can still hear you. Carry on. Okay,
that's fine. Yeah. So I haven't got time to go into all the ways that is wrong and bad, basically. But that's a massive experience that a lot of kids have with those sorts of things. So I think there's definite work to do around that. And approaching that in a much more, not wanting to get the language tripped up here, but what does mean? What does it actually mean to think about mean, and what mean is, and stuff like that. So I think that's one. And then, all maths teachers have different things that they say, oh, I don't like this, or I really like this. Teaching trig to foundation kids is something that a lot of maths teachers just shake their heads at in despair. But all of these things are actually part of that tapestry, that journey, and they all link together. So actually, if we really appreciate that, and we approach the subject teaching in a way that is designed to make that explicit to pupils, then I don't think there's anything really that I would be saying, well, that definitely needs to come out, or that's something that people should feel like, well, I don't really want to be teaching that. The last one I will mention is statistics generally, because there are people out there that think that that's not mathematics at all and should be tackled in the social sciences, but I'm not one of those people.
Well, I was good at statistics. When I did my A level, I couldn't do mechanics, hated it, but I was very good at statistics, and actually I really liked constructions. I don't understand what all the fuss is about. But you mentioned there about time and teachers not having time to really think about these things. And in just over 3 months' time, or in about 3 months' time, students are going to be starting their GCSEs and their A levels, and all of a sudden, teachers up and down the country in maths departments are going to have gained time to think about. And some teachers are probably going to go, oh, I think we need to update our schemes of work, and we need to update how we sort of teach these particular things. And they might pick up your book. Any words of advice for them sort of going in through that updating schemes of learning and using conceptual maths to sort of help them with that?
Yeah, there is some advice, and it's right there on the first page in the tagline, and that is think about what you want kids to learn about. Yeah. I want kids to learn about this. So when I'm teaching, whatever it is, negative integers, what do I want kids to learn about negative integers? Not just what do I want them to be able to do with negative integers? I want to be able to add them and subtract them and multiply with them and divide them. Yeah, that's great. That's a given. Yeah. What do I want them to learn about negative integers? What do I want them to learn about this, about that? Make that your start point always. The poll was actually there on Teacher Tap the other day when, and thankfully, the vast majority of teachers responded in the positive for the, or what I would see as the positive for this is what's the first thing you think about when you come to planning a lesson? And the options were, the activities I'll use, or the questions I'll ask, or some other bits and pieces. But the top one, and it was the one that most people picked, is what I want the kids to learn about. But in maths, you've got to be careful with that, because the phrase about and the phrase to do can become like, I want the kids to learn about. Well, I want them to learn about the column multiplication algorithm. Well, okay. Have they learned enough about multiplication first? Again, coming back to that idea. So separate in your mind the idea of what you want them to do and what you want them to learn about, and start with what do you want them to learn about? And then where that leads to, okay, well, once they've learned about this, they should be able to do this, this, and this. So then let's go with that.
Thank you. And got one final question, because you've been with us for nearly an hour and a half and you've been fantastic, Pete. Do you have a third book in you?
Yes, I'm not going to say what that is yet, or what I will say is that it's not going to be directly related to teaching maths, because I think, when you've written a combined total of 220 odd thousand words with visible maths and conceptual maths about ultimately the ways you think maths should be taught and the way, and good things that you can do in the classroom, then if you've still got more to say at that point, you've probably not been succinct enough. So there is a third book. It's currently being worked on. It's in actually the final stages, but it's going to take a slightly different bent, and it's not going to be directly related. It's still going to be in the maths education sphere, but it's not going to be sort of directly related to approaches for teaching mathematics and what kids should be getting out of that. It's going to be slightly different. So I won't do the reveal now because it's not yet sort of finalized and finished and things like that. Although Crown House provided it once it's all together and they've seen it, Crown House are looking to publish it. So yeah, later this year there might well be something, but in terms of ways of sort of approaching the teaching of maths and the students learning maths, I think visible maths and conceptual maths is probably about all I've got to say on the subject.
Well,
unless I come up with some new stuff, of course, or unless I change my mind on things, or I'm always learning myself. So maybe in a few more years, when I've learned some more, maybe there'll be some updates.
That's the beauty of our subjects, isn't it? That it's never finished, and that's the beauty of curriculum. It's never finished, and that it's always changing, in that we have new ways of explaining things. Pete, you've been an absolute legend. Thank you very much for giving up your hour and a half to talk about.
No, it's been a pleasure, Tom. It's been an absolute pleasure.
And thank you very much. And I hope you have a good evening, and I hope you have a good half term next week as well.
Yes, thank you very much. And thank you very much to all of those people that have been listening. I know some of you have been listening for the whole hour and a half. So I applaud you very well. Thank you very much for that.
No problem. In terms of final mopping up for Teachers Talk Radio wise, I wanted to just plug that on Friday, the 3rd of March, we've got the NEU General Secretary debate with Daniel Kebede and Niamh Sweeney. They're going to be talking about their policy positions, their platforms, and how the NEU would change under their leadership in their contest for a 5-year term to replace Dr. Mary Bousted and Kevin Courtney. You can catch me again on Sunday morning on the Weekly Review. That's at 10 a.m. That's streamed live on YouTube, on LinkedIn, and on our Twitter feed as well. This Sunday, I am joined by Nathan Ginn, who's also in the studio, Leanne Lax, and Ben Thomas. And then the following 27th of February, Weekly Review, I'm joined by Lucy Newberger, Joe Fox, and somebody else to be confirmed. But thank you very much for joining us on Teachers Talk Radio tonight. It's been an absolute pleasure talking to Pete and refreshing my memory of maths. And I hope you've enjoyed listening to him and his book as much as I have. The book is available via Crown House. But for now, I shall leave you this evening. And so... yeah, without any further ado, tune in, talk it out, and see you later.
You've been listening to Teachers Talk Radio. Tune in live and listen back at ttradio.org. We look forward to hearing from you next time on Teachers Talk Radio.